In this video, we're going to be looking at how to name aromatic compounds. Now, first things first, let's have a think about what we mean by an aromatic compound. An aromatic compound is anything that contains a benzene ring. Okay, so you can draw your benzene rings like this. That's just representing the delocalized model. You can also draw Kekulé's benzene with the alternating double and single bonds. Both are acceptable. So anything that contains a benzene ring is classed as an aromatic compound. So this is the simplest aromatic compound, which is benzene, and therefore is just called benzene. And two key words that I just want to discuss are a parent compound and a substituent. Right, so the parent compound, for example, if we just go for this compound over here, okay, the parent compound in this case is the longest carbon chain, and in this case it is a butane chain. The parent name always goes at the end, so this name is going to end in butane. The substituent is any branches or other atoms coming off of it, and in this case we've got that methyl coming off of that parent butane chain. It's coming off of the second carbon, and therefore the substituent is called 2-methyl, and the substituent name goes at the beginning, the parent name goes at the end. So this molecule over here is called 2-methyl butane. We're now going to apply the same principles to aromatic compounds. So we need to decide basically when, what is the parent compound and what is therefore the substituent. So let's start off simple. Let's go for this compound over here. So in this case, the parent compound is going to be benzene. Okay, so our benzene over here is our parent compound, so therefore the name is going to end in benzene. And the substituent is anything coming off of that benzene. So we've got over here this alkyl chain. This one here is called methyl, and therefore this compound here is just simply called methyl benzene. Right, let's do another one. So if we've got this compound here, so again the parent is our benzene, so the name is going to end in benzene, and now this alkyl group here, 2 carbons, and therefore this is ethyl. This compound here is called ethyl benzene. Fairly straightforward up until you get to 7 carbons in the alkyl chain. So if you have, I'm going to draw this out, 1, 2, 3, 4, 5, 6, 7. So as you can see, we've got 7 carbons in this chain coming off of here. If you have 7 or more carbons in your alkyl chain, the benzene ring is no longer the parent compound. It becomes a substituent, right? So now this alkyl chain is the parent compound. So let's number this parent compound. So 1, 2, 3, 4, 5, 6, 7. You've got 7 carbons, and therefore it should end in heptane. And now, as we said, this benzene ring is a substituent, and as a substituent, we don't call it benzene anymore. We actually call it phenyl. So benzene rings as a substituent, we call it phenyl. And as you can see, this phenyl group is coming off of carbon number 1. So this is called 1-phenyl heptane. All right, so if we have 7 or more carbons coming off, benzene becomes a substituent. So let's just do another example of that. Okay, so again, we've got 7 or more carbons coming off. In this case, let's just see what the parent compound is. So I'm just going to number it 1. So longest carbon chain actually starts from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the parent compound is nonane. So it's going to end in the name nonane. We then look at the benzene ring as a substituent. So again, it's going to be called phenyl. It's coming off of the second carbon. So this is called 2 phenyl nonane. Okay, so the limit is up to 6 carbons. If it's got 6 carbons, it's going to be, the benzene ring is going to be the parent. If it's got 7 or more, it is going to be a substituent. Right, let's look at compounds that aren't hydrocarbons. So let's say in this one over here, we've got a chlorine atom coming off. So again, your benzene ring is the parent, so it's going to end in benzene. And chlorine as a substituent, it's classed as chloro. So this compound here is called chlorobenzene. Same applies for any other halogen coming off of it. So for example, if we had bromine, this would be called bromobenzene. If we had iodine coming off it, it'd be called iodobenzene. Fluorine coming off it, it'd be called fluorobenzene, and so on. All right. Okay, so that's the halogens and substituents done. Let's now just have a look at a new type of functional group that we haven't really covered, and that is this group over here. So we've got NO2, nitrogen-based compound. So let's have a think as to what this compound here is called. In this case, again, benzene is the parent. Now this NO2 up here, we call this a nitro group. So therefore this compound here is called nitrobenzene. Right, let's look at some more examples. So another one is where we have a carbonyl functional group coming off. So carbonyl being a C double bonded to an oxygen. So something like this. In this one, the functional group, we've got 2 functional groups, in fact. We've got a carbonyl, so that's a ketone, and we've got a benzene ring. So we've got 2 functional groups. We've now got to decide which one's the parent and which one is our substituent. Now, in this case, when you have a ketone, a carbonyl coming directly off of a benzene ring, this over here is going to be, this whole thing over here is going to be the parent compound. So this one over here is a ketone. It should end in -one. It's got 2 carbons, and therefore this one is ethanone. Okay, so -one being a ketone, ether being the fact it's got 2 carbons in it. So the ketone is the parent compound, and the substituent is now our benzene ring. So as a substituent, we call it phenyl, and therefore this compound here is called phenyl ethanone. So that's the general rule. There are exceptions to these rules. So the ones that you can't name, you just have to memorize the names. So the exceptions, there are 3 exceptions. So we're just going to have to memorize these names. The first one being this compound over here. Right, so based on the rules that we've just covered, given that we've got a functional group coming off of our benzene ring, this should be the parent. It's a carboxylic acid. It's got 1 carbon, so therefore you would assume it's called methanoic acid. And therefore this should be a substituent, so you would assume it is phenyl methanoic acid. Okay, the truth is this is not the name. The name that we go for this one is benzoic acid. So it doesn't follow any of the rules that we've covered. This is one that you just have to know it's an exception. Right, so that's exception number 1. Don't know if I'm going to fit them both on here, but exception number 2 is this one over here. So again, you've got a functional group coming off the benzene ring. This one is an aldehyde, so it should end in al. It's got 1 carbon, so you'd assume it's going to end in methanal. So methanal being the parent compound, this being the substituent, so you would assume it is called phenyl methanal. like that. Truth is, it's not called that. We call this benzaldehyde. Okay, so again, a name you just need to memorize. It's an exception to the rules that I've taught you. So that's exceptions 1 and 2. I'm just going to cover exception number 3. So exception number 3 is this one here. Okay, so this over here is an amine group. So usually when we have an amine group, we give it the prefix amino, and therefore you would assume this is called aminobenzene. Okay, don't worry too much if you haven't seen that amine group before. We do cover it later. But the truth is, it's not called aminobenzene. We call this compound here phenylamine, spelt phenylamine. Okay, so the amine in this case is actually the parent. The phenyl, the benzene ring is the substituent. So this is called phenylamine, or pronounced phenylamine. So they are your 3 exceptions that you need to know. Let's now have a look at when you have more than one substituent on the benzene ring, because so far we've looked at when we have just one substituent, it's monosubstituted. Let's now have a look as where we have di or more substituted benzene rings. Okay, so first things first, the position of the substituents is now important, right? So what we're going to have to do is we number the carbon atoms in our benzene ring. So that's important. It will tell us which number carbon we find those substituents on, right? So again, in this one, we've got a benzene ring. That's going to be our parent. We've got our methyl groups. They are our substituents. So it's going to end in benzene. It ends with a parent name. We now have 2 methyl groups. Okay, so 2 methyl groups. So therefore we call it dimethyl. So we've got dimethyl benzene, but those methyl groups at the moment could be on any carbon. So we now need to specify which carbon they are found on. So the aim is to have the methyl groups on the smallest number carbon. So the best way to do that is start as that one being number 1. If I go clockwise, this one will end up on number 3. I don't want to go anti-clockwise because that's going to therefore end up on 1, 2, 3, 4, 5. And that's a bigger number than 3. Okay. So this compound here is therefore called 1,3-dimethyl benzene. Right, let's move on. Let's try this one here. So again, we've got a parent compound. This one is benzene. And we've got 3 chlorines attached to this one. So this is going to be trichlorobenzene. Trichlorobenzene, and again you've got to put numbers on your carbons in the benzene ring. In this one it doesn't actually matter which direction you go in. So as you can see, this is called 1, 3, 5. So you put those numbers in order. It is 1, 3, 5 trichlorobenzene. Okay, let's do another example where we now have different types of substituents. Like so. So what we now need to do is decide how to name this one. Now again, we've got a nitro compound, we've got a chloro, so we've got a nitro substituent, we've got a chloro substituent. In this case, your benzene ring is the parent, so the name is going to end in benzene. We've got 2 substituents, we've got nitro and we've got chloro. Okay. What you now need to do is put them in alphabetical order. So chloro goes before nitro. You pick the one that is last in the alphabet. So in that case, it's going to be nitro. And you put that with the benzene. Like so. And the one that is last, the one that you've put with benzene, the carbon to which that is attached to becomes carbon number 1. So this has got to be carbon number 1. And then all you do is you number to put, so I'm going to go clockwise to put the chloro on the smallest number carbon. And now you put the first, so the first one in the alphabet was chloro, you give that the number 3. So therefore this compound here is called 3-chloro-nitrobenzene. You do not need to put the one with the nitro, because putting nitro with benzene tells you that that nitro is already on carbon number 1. So you don't need to call this 3-chloro-1-nitrobenzene. Let's do another example. Right, so 2 substituents again. We've got iodo, we've got methyl. I'm going to write them down. So you've got methyl and you've got iodo. So again, the parent compound here is benzene. It's going to end in benzene. You now decide out of iodo and methyl which one is last in the alphabet. In this case, it is methyl. So you put methyl with benzene. And your methyl, the carbon to which the methyl is attached to, becomes carbon number 1. Again, it doesn't matter which way I number now. And therefore, your iodo is on carbon number 4. So therefore, this is called 4-iodo-methylbenzene. Okay, let's now have a look when we have 3 substituents. So we've got, in this one, we've got nitro, we've got bromo, and we've got iodo. Right, so again, in this case, the parent compound is our benzene. Again, out of all 3 of these, which one is last in the alphabet? In this case, it's our nitro. So nitro goes with benzene, and our carbon with the nitro becomes number 1. Keep going in this direction. And now we've got to put our bromo and our iodo in order. You again go alphabetically. So first in the alphabet, and therefore first in the name, should be your bromo. Doesn't matter about the number it's attached to. You don't go in the order of the numbers, you go in the order of the alphabetical names, and therefore bromo is first. So it should be, so bromo is on carbon number 2, so it should start off with 2-bromo. And then we have 3-iodo, nitrobenzene. So just bear in mind, these 3 are in alphabetical order always. And the one that is last is technically is classed as your carbon number 1, but you don't need to put the 1 in front of, in this one, in this case, don't need to put the 1 in front of nitro. Right, last example. So we've got 2 substituents coming off here, but now remember the benzene ring is not the parent compound because this compound here is one of your exceptions. So always remember, always look for those exceptions because they are more important and therefore they are the parent compound. So in this case, this compound here is your parent compound. And if you remember, as we've covered, it is called benzoic acid. So therefore this is going to end in benzoic acid, and the benzoic acid, so where the acid part is coming off, that is carbon number 1 always, and therefore this compound here is called 3-iodo-nitrobenzene. 3-nitrobenzoic acid.